In this video, we'll be taking up the Chapter 6 review homework sheet. So for the first question, they wanted me to graph half to the power of x, which is something you learn in grade 11. That's our exponential decay function. They also ask us to state some key properties: domain, range, x-intercept, y-intercept. When is it greater than 0? When is it less than 0? Increasing, decreasing, and asymptotes. So all that stuff, no problem. All of that is strictly grade 11. But what is grade 12 is the inverse of that function, because the inverse of an exponential function is a logarithmic function. That's the very first thing we learned in this unit, because we wanted to introduce logarithmic functions. And you don't want to introduce it as something entirely new, because that's definitely not what we want to do. It's based on something you already know. It's based on a relationship you already know. Anyways, once we graph the inverse using the y equals x line, you state the properties of the logarithmic function, and that's it for number 1. So for question 2, we're rewriting in logarithmic form. So that was very important, because that helped us solve the logarithmic equations and the exponential equations. So going from logarithmic form to exponential form was really important. So question 2, you're going from exponential to logarithmic form. In question 3, we're going from logarithmic form to exponential form. Question 4, we're just evaluating some logarithms without using a calculator. So all these logarithms, you can evaluate them as long as you know your powers. Like you need to know 4 cubed is 64, or 10 cubed is 1000, so forth and so on. For question 5, it's just talking about one of the relationships between logarithms and powers, and that they are inverses of one another as long as the bases are the same. And of course, we also talked about the restrictions on the base of the logarithm and on the powers. We said that they have to be greater than 0 and they can't be 1. And the reason we have these restrictions is based on the restrictions on the base of an exponential function. We can't let it equal to 1, because you won't get that beautiful exponential function curve. You'll have a constant function. You'll have a horizontal line. And you can't have the base be less than 0, because that will generate a lot of undefined values. So yeah, the base can't be has to be greater than 0 and can't be 1. For question 6, they basically gave us a bunch of transformations and we had to state the equation. Question 7, I didn't use graph paper, but I generated a mapping rule based on the transformations. I got the original points, I found the new points using the mapping rule, and I plotted what I could. But you can use my points, and then you can use graph paper and generate a very pretty graph. But the key thing I want to mention about the graph is the location of the vertical asymptote. That is dictated by the horizontal translation. Question 8, you're just evaluating logarithms. Use the power law of logarithms to help you out. Question 9, you're solving some exponential equations. Really not much to say. Just use a logarithmic form to help you out. Now, actually 9C is interesting because it's a little different. You're solving for the base here, so what you have to do, you actually don't need logarithmic form. You just take the 8th root of both sides, but be careful, that means it's plus or minus now. Okay, question 10, you have a relationship between voltage and, intensity and time. Intensity and time. So if they give me the time, I can solve for the intensity, and if I am given the intensity, I can solve for the time. You're basically working with an exponential equation, which is something you did in grade 11, but what 10b you couldn't do because you weren't introduced to logarithms in grade 11. In grade 11, you're expected to just guess and check, which was very, very tedious and time consuming. Question 11, we have our Richter scale. So I didn't even bother using the formula. I know that the Richter scale works because the way it's designed is that each increase in 1 unit on the Richter scale represents a 10-fold change. So I found the difference of the two measures on the Richter scale by the earthquake, and I took 10 to the power of that value. And that is based on my understanding of how the Richter scale is designed. So that will give me the ratio of the intensities of the two earthquakes. So it's about 251 times as intense, the one that's measuring 7.1 on the Richter scale compared to the one that measures 4.7 on the Richter scale. And then they gave me another one where this earthquake is 450 times as intense as another earthquake that measures 5.2. So 5.2 plus log 450. If it was, instead of 450 times as intense, if it was just 10, then you add by log 10, which is 1, right? So this adding by log of whatever the ratio is makes perfect sense. Okay, question 12 is a pH question. So this one is based on my understanding of the pH scale, and the design of the pH scale is essentially the same as the design of the Richter scale. 1 unit change is 10 times change. So if it's 1 unit down on the pH scale, it's 10 times as acidic as before. Anyways, they gave me the pH, and I can solve for the concentration of hydronium ions. And if they give me that concentration, I can solve for the pH. The question 12 was actually easy. They didn't give me 2 different solutions. But easily, what you can, if you were asked to compare the concentration of hydronium ions, you can just use the same relationship as I did for 11A. Okay, so that was chapter 6 review.